Okay. All right. I was going to show you this whole simulation thing, which is really kind of nice. It's pretty nice simulation. They've changed it a little bit. So, but anyway, so here's our parameters that we're working with. We got to find the height to the left, and we got to find the maximum height. Now remember, it said the maximum height from the ground. And remember, the lip of this thing is 1.4 meters. So whatever we do, we're going to wind up adding that 1.4 meters, and that'll be our maximum height. Okay? All right, so here we go. Let's take a look at what's in the x direction, and look what's in the y direction. All right, first thing, v naught in the x direction, the initial velocity in the x direction, is 6.7 meters per second times the cosine of 60. V naught y, 6.7 meters per second times the sine of 60. Okay? All right. The range is going to equal from here to the maximum height. The range is going to equal v naught x times t max, what I call the maximum, the time of the maximum height. In other words, it's going to, the range that we're after, here's the ramp, here's the tip of the ramp, and this is 0, 0, and this is at negative 1.4 meters. So we're going to take the difference. So we're going to take the maximum height. It's going to get up here to the maximum height, and we're going to find this range that it went. Here's our R, the range to get to the maximum height before it started to come down. Okay? Okay. So that's all I can do in the x direction. Now, if we wanted to find the range total, this would equal v naught x times the time, the total time it's in the air. Now this problem's would be a little bit trickier because it's going to reach this point and then it's going to still be going down another 1.4 meters. All right, so its range will be a little bit further. That's kind of a harder problem. Okay, so let's figure out everything in the y direction then, and then we'll go on to part 2. So I've got the acceleration. Oh, the acceleration in x direction, 0. Acceleration in y direction, negative 9.8 meters per second squared. Okay. The final velocity in the y direction at the maximum height would equal 0. The final velocity at the maximum height in the x direction is equal to v naught x. So now we can find the time it took to get to the maximum height. Okay, T max is equal to, and we'll pause that right there and get to it